By all rights, Saturn shouldn't be making any noise at all. Space is a vacuum and sound simply cannot travel through empty space. And yet right now, researchers are studying an unsettling recording of Saturn humming a genuine signal captured by a NASA spacecraft and hidden inside years of data. That hum turns out to be something scientists only recently realized had been sitting there undetected the whole time, an entirely new kind of radio emission unlike anything else Saturn produces, and one that nobody has fully figured out yet. And that's only the start. This planet hosts a storm shaped like a near-perfect hexagon that, by the rules of physics, has no business existing. Its rings are very likely the debris field of a moon that was torn apart. And roughly once every 3 decades, its atmosphere erupts into a storm so enormous that the entire Earth could be tucked inside it. Stay with me, because by the end you'll understand why researchers keep calling Saturn one of the oddest bodies in our solar system. Let's begin with the sound, since figuring out how it's even possible is the key to grasping just how strange this planet is. But Saturn isn't silent because it possesses a massive magnetic field that functions almost like a giant natural antenna. When solar wind, the endless stream of charged particles flowing from the sun, crashes into Saturn's magnetosphere, it produces strong radio emissions near the planet's poles. These aren't sound waves in any conventional sense, they're electromagnetic radio waves, but scientists can take that raw radio data and shift its frequency down into a range. Human ears can pick up, which is exactly what NASA did, using readings gathered by the Cassini spacecraft. The outcome is that eerie pulsing hum often shared around Halloween, a genuine sonification of real data, not something manufactured for spooky season content. This particular signal has been recorded and studied for decades, and scientists had grown familiar with its usual rhythm and pulse. But in 2022, a research team combing back through old Cassini archives stumbled on something that had apparently gone unnoticed the entire time. A completely separate signal buried within one that didn't match Saturn's typical radio behavior at all. It was named Saturn Anomalous Myriometric Radiation, and described in a peer-reviewed study published in Geophysical Research Letters in August 2022. Led by scientist S.Y. Ye, the team identified 193 distinct occurrences of this signal across the full Cassini archive. Here is what makes it so odd. Saturn's normal radio output follows a predictable pattern tied to the planet's rotation and its interaction with solar wind. This new signal breaks that pattern entirely. Its frequency drifts over time in ways the regular emissions never do, and some individual events lasted 11 hours or more. Picture Saturn having a steady, familiar heartbeat that scientists have monitored for decades, and then suddenly noticing that every so often an entirely different rhythm starts playing on top of it, coming from somewhere unknown for reasons nobody has pinned down. Researchers can tell it originates somewhere near Saturn, based on how its strength changes with distance, but the actual mechanism behind it and why it behaves so differently from the planet's usual signals remains an open question in planetary science. Eventually, that lid gives way. Enormous volumes of warm, moisture-rich gas surge upward in a runaway process, triggering a storm system thousands of times more powerful than anything Earth produces. As the rising water vapor condenses, it releases massive stored heat, which fuels the storm further, and the whole system explodes outward with winds reaching 310 millimoles. Scientists still aren't entirely sure why this cycle repeats with such precise 30-year timing, but the leading explanation ties it to Saturn's long seasonal cycle. Since one full orbit around the Sun takes almost exactly 30 Earth years. Inside these massive white storms, things happen that simply aren't possible anywhere on our own planet. Cassini's instruments recorded intense, nearly continuous lightning, sometimes flashing more than 10 times per second at the storm's peak. This supercharged lightning strikes down to incredible depths, punching through dozens of miles of dense atmosphere to reach the deep water cloud layers where these massive electrical charges actually originate. The sheer energy involved is staggering. Scientist Georg Fischer noted that a single one of these storms releases roughly the same total energy Earth receives from the Sun over an entire year. That level of power connects to something even stranger about Saturn as a whole, sometimes called the planet's energy paradox. Saturn actually radiates almost twice as much heat into space as it receives from the Sun, despite sitting nearly 1 billion miles away from our star. In other words, Saturn is generating a substantial amount of its own internal warmth. Its core has remained extremely hot since the planet first formed, and deep inside, a bizarre process called helium rain is constantly underway. Under Saturn's extreme internal pressure, liquid helium doesn't fully mix with the surrounding liquid metallic hydrogen. Instead, it separates out, much like oil separating from water, forming heavy droplets that slowly sink through the hydrogen layer toward the core. This has been happening continuously for billions of years, and the friction generated by that constant droplet fall releases a tremendous amount of additional heat, helping explain why Saturn runs so much hotter internally than sunlight alone could account for. This deep internal energy also shapes Saturn's polar regions in unusual ways. Cassini discovered that Saturn's North Pole continues glowing intensely in infrared light, even during the depths of its multi-year-long polar night, a period when direct sunlight hasn't reached that region for years. Researchers are still working out exactly how the planet's magnetic field, its auroras, and this deep internal heat interact to sustain that glow in near total darkness. It's one more example of how much about this planet remains only partly understood. Even after decades of dedicated study, Saturn's magnetic field itself is worth pausing on because it's genuinely unusual, even compared to other planets with strong magnetic fields like Earth and Jupiter. Most planetary magnetic fields are tilted at a noticeable angle relative to the planet's rotation axis, which is actually what lets scientists measure a planet's precise rotation rate by tracking how the magnetic field wobbles. As the planet spins, Saturn's magnetic field strangely appears to be almost perfectly aligned with its rotation axis, off by less than 1 degree. That near-perfect alignment has made it surprisingly difficult for scientists to pin down Saturn's exact internal rotation rate, something researchers have had to work out indirectly using tools like that anomalous radio signal and other magnetic field measurements gathered during Cassini's final orbits, rather than reading it directly off the magnetic field's tilt as they can with other planets. None of these discoveries would have been possible without serious engineering. The instrument responsible for capturing Saturn's radio emissions is called the Radio and Plasma Wave Science Instrument, a set of long antenna booms mounted on Cassini, sensitive enough to detect radio waves at frequencies measured in mere kilohertz coming from a source hundreds of millions of miles away. Turning that raw radio data into an audible hum required scientists to compress years of frequency shifts into a short, listenable clip, essentially speeding up and pitch shifting a signal that would otherwise be silent to human ears, even if you were floating right next to Saturn in a vacuum suit. That same translation technology is what lets us hear the sun's radio output as well, giving us a way to experience data that has no natural sound at all. The James Webb Space Telescope has also turned its instruments towards Saturn in recent years, capturing detailed infrared observations of the planet's rings and layered atmosphere. Because Saturn's methanoic atmosphere absorbs most incoming sunlight at infrared wavelengths, the planet itself appears strikingly dark in these images, while the icy rings, which reflect sunlight very efficiently, glow brightly by contrast. This kind of infrared imaging lets scientists study cloud structures and chemical layers at different depths in Saturn's atmosphere that are simply invisible in ordinary visible light photographs, adding yet another layer of detail on top of everything. Cassini gathered up close. Almost everything humanity currently knows about Saturn in this level of detail we owe to the Cassini spacecraft. Cassini arrived at Saturn in 2004 and spent 13 years orbiting the planet, gathering data on its rings, moons, storms, and magnetic field. When its fuel supply began running low in 2017, NASA engineers made a deliberate choice rather than risk losing control of the spacecraft and having it accidentally crash into one of Saturn's icy moons, like Enceladus, which scientists believe may harbor conditions capable of supporting life beneath its frozen surface. They chose to send Cassini directly into Saturn's atmosphere on purpose. Among the very last images Cassini transmitted back to Earth was a striking shot of Enceladus rising above Saturn's horizon. Shortly after the spacecraft entered the planet's upper atmosphere at tremendous speed, breaking apart in the intense heat until its final faint radio signal cut off completely. That's how one of the most remarkable exploration missions in human history came to an end, with Cassini quite literally becoming a permanent part of the very world it had spent over 13 years studying. So where does all this leave us with Saturn today? We have a planet emitting a mysterious radio signal that scientists only recently discovered hiding inside decades of old data, one that still doesn't fit neatly into any existing model. We have a storm shaped like a perfect hexagon defying basic fluid dynamics that has held its geometric form for more than 40 years. We have rings that, based on current research, are almost certainly the shattered remains of a destroyed moon formed far more recently in the planet's history than almost anyone originally expected. And we have an atmosphere that quietly builds up energy for decades before violently erupting into storms massive enough to swallow our entire planet on a schedule tied to Saturn's own 30-year journey around the sun. Every one of these mysteries was uncovered using real spacecraft data collected by real missions and confirmed through real published research. Nothing about Saturn needed exaggeration to sound remarkable. The documented facts about this planet are already stranger than fiction. As instruments keep improving, and researchers keep revisiting old mission archives with fresh eyes, the same way that TEAM did with Cassini's radio data. Back in 2022, there's a very real chance Saturn still has more surprises waiting to be found, hidden somewhere in data we already have, simply waiting for someone to notice it. And that last point is really worth sitting with. The anomalous radio signal we started with wasn't discovered by a brand new spacecraft or some cutting-edge telescope. It was sitting quietly inside data Cassini had already collected, and sent back years earlier data that plenty of scientists had already examined before someone finally noticed a second signal hiding beneath the first. That means the next major discovery about Saturn doesn't necessarily require a new multi-billion-dollar mission. It might already be sitting in an archive, somewhere in old images, old radio recordings, old temperature readings, simply waiting for the right person to look at it, again with a fresh set of questions. Modern data storage and processing technology now lets researchers reanalyze decades of raw spacecraft data far more efficiently than earlier generations of scientists ever could, which means old missions like Cassini and even Voyager keep producing new science long after the spacecraft themselves have gone silent. Stay curious, because if a planet nearly 1 billion miles away can still surprise scientists working with decades-old information, there's no telling what we might still learn about our solar system next.